As more organizations explore AI agents to automate business tasks, one concern rises above all others: reliability. When an AI agent touches money, customers, compliance, or core operations, mistakes are not just inconvenient, they can be costly. In this video, we will explain what AI agent reliability actually means in a business context, how reliable agents are designed, which tasks can safely be automated, and why human oversight remains essential for critical decisions. Let us start by defining reliability in practical terms. AI agent reliability means an agent consistently produces correct, safe, and explainable outcomes within clearly defined boundaries. In business environments, reliability is not about occasional success. It is about predictable behavior across real data, real workflows, and real constraints. A reliable agent behaves like production software, not a chat experiment. At AI Smart Ventures, reliability is evaluated across 6 dimensions. Accuracy refers to producing correct outputs. Consistency means stable behavior across similar inputs. Robustness measures how well the agent handles edge cases. Safety ensures the agent avoids harmful actions. Auditability provides traceable decisions. Resilience ensures the system fails safely and escalates issues when needed. These dimensions guide how agents are designed, tested, and deployed for critical tasks. A common question is how organizations reduce risk when using AI agents for business automation. The answer is layered safeguards. Instead of relying solely on a model, reliable systems place controls around it. These controls define what the agent can do, how outputs are validated, and when human intervention is required. Task boundaries and permissions are the first safeguard. Each agent has a clearly defined scope with explicit allowed actions and hard limits. Validation checks follow. Outputs must meet required formats, schemas, and business rules before any action is taken. Agents also rely on authoritative data sources such as CRMs, ERPs, databases, or approved knowledge bases. This prevents guessing and hallucination. Human approval gates are another critical layer. High-impact actions such as payments, access changes, or compliance decisions require explicit approval based on thresholds set by the business. Secondary verification adds another check for sensitive steps. Monitoring and alerts track error rates, escalation frequency, and unusual patterns so issues surface early. Finally, testing and change control ensure updates are reviewed and validated before release. This design raises another important question. Do AI agents ever run fully unsupervised in high-stakes workflows? In most cases, no. Fully autonomous execution is reserved for tasks that are narrowly defined, strongly validated, and low-risk or reversible. For many critical tasks, the safest structure is agent recommends and human approves. This still reduces cycle time significantly while protecting the organization. So which tasks are safe for AI agents to handle independently? Agents perform best in workflows that are repetitive, well-defined, and measurable. Data extraction and normalization is a common example. Agents can pull structured fields from invoices, intake forms, emails, or standard documents and format them for downstream systems. Ticket triage and routing is another area. Agents can categorize requests, assign priority, tag issues, and send acknowledgments using clear rules. Routine communications are also well-suited. Drafting templated follow-ups, appointment reminders, status updates, or internal notifications can be automated safely when content is constrained and reviewed during setup. Back-office orchestration is another category. Agents can create tasks, update CRM records, generate reports, and move work through stages when outputs are validated and reversible. What is not safe to run fully autonomously is work that requires judgment under ambiguity or creates irreversible impact. Large payments, legal approvals, policy exceptions, and security access changes fall into this category. For these tasks, Agents support decision-making rather than replacing it. This leads to the question of why human oversight remains necessary even as models improve. AI systems are probabilistic. They can misinterpret edge cases, shifting business rules, or incomplete inputs. In critical workflows, rare mistakes can be more expensive than thousands of correct outputs. Human oversight is therefore a feature, not a weakness. Human review is especially important when decisions involve legal exposure, financial risk, compliance obligations, safety outcomes, or reputational impact. Reliable systems include clear escalation paths. Anything outside defined boundaries is paused, flagged, and routed to the appropriate person with supporting context and evidence. Another important consideration is what happens when an AI agent gets something wrong. Reliability planning includes failure scenarios. The goal is to detect issues quickly, stop further impact, and support resolution. Pre-action validation blocks risky outputs, such as missing fields or policy conflicts. Exceptions trigger escalation with full context. Audit trails capture every step so teams can understand what happened and why. Post-incident tuning is also part of reliability. Rules may be updated, prompts refined, tool constraints tightened, test cases expanded. Reliability improves over time because failures are treated as signals for improvement rather than surprises to hide. Data protection is another core element. AI agents should never become a backdoor to sensitive information. Data safety depends on how access is designed and governed. Role-based access controls ensure agents only see what their role requires. Secure environments keep sensitive data within approved systems. Redaction and minimization remove unnecessary fields before processing. Safe logging practices support auditability without exposing confidential content. Compliance-aware workflows align deployments with regulatory requirements and internal governance policies. This design helps security and compliance teams work with AI systems rather than fighting them. A common misconception is that reliability slows progress. In practice, the opposite is true. Reliable systems build trust. Trust enables adoption. Adoption unlocks value. When leaders know agents will behave predictably and escalate when uncertain, they are more willing to expand automation. Another misconception is that reliability means perfection. No system is perfect. Reliability means controlled behavior, transparency, and safe failure. It means leaders understand where AI can act, where humans must review, and how issues are handled. Successful organizations treat AI agents like junior operators. They are given clear instructions, limited authority, supervision, and feedback. Over time, responsibility may increase, but only when evidence supports it. This mindset prevents overreach and supports steady progress. AI agent reliability is not achieved by buying a tool. It is achieved through design, safeguards, governance, monitoring, training. These elements turn AI from an experiment into infrastructure. AI Smart Ventures supports organizations by designing agents that behave like production systems. The focus is on safety, auditability, and alignment with real workflows. Each deployment starts with clear boundaries and success criteria, then evolves through measured expansion. To conclude, automating critical business tasks requires more than capability. It requires reliability. Reliable AI agents operate within defined limits, use trusted data, escalate uncertainty, and keep humans accountable. When reliability is designed in from the start, organizations can move faster with confidence rather than fear. This is how AI becomes a dependable part of business operations, not a source of risk.